Welcome to a high summer, sunny, early morning here on board Charis. I want to talk a little bit today about a question that I'm asked probably more than any other by people who are interested in doing a solar installation on their boat. And that question is, how much solar panel do I need? There's some good answers to that question. There's one way to answer that question if you have unlimited amount of space. If your only limitation is how much you spend on the system, rather than where you put the panels. Multi-hulls, wide beam catamarans, boats like that often fall into that category. But on an older boat like Charis, particularly these narrow-beamed 1960s CCA boats, the answer to the question of how much solar panel do you need is often a question. The question is, how much do you have room for? The basic reality is, unless you build an arch or if you have a bimini that you can cover with solar panels, really your limitation is what space do you have, what area do you have where they're not shadowed. And on Charis, I've kind of cheated a little, and I've expanded my space with what I like to call my solar wings. These are basically just L-shaped arms that allow me to mount the panels outboard of the beam. Now that has pluses and minuses, as you can probably guess. You gain a little extra real estate, but you can't raft to another boat and leave the panel up. You can't even go alongside a dock and leave the panel up. So you've got to have the ability to fold that panel. You've got to remember to do it, I guess is what I should say. Now that ability, though, gives it another level of flexibility and output potential, and I'll demonstrate that in a minute. So what I have right now on Charis are two 100 amp rigid panels back aft here on the wings, and up forward, sort of lashed to the deck tender, is a foldable portable panel that just plugs into a socket here. It's got its own regulator, it's got its own monitoring meter, and that's a fully portable setup that I can take off at any time, move around, even take ashore and use with a power station when I'm doing jobs at the field where I need to run a laptop or something. That panel is super handy for that regard, and it does a good job. So I've got 300 watts of panel. These two aft panels that I replaced about 5 years ago, they replaced two Siemens M55 panels, which were approximately the same square area and weight. So over the course of 25 years, those Siemens panels worked flawlessly. They still output their rated 55 watt capacity, but the simple truth was, for the same weight and square area, I was able to almost double the output potential. So those two panels feed together to a single charge controller that's in a sail locker beneath me here. So going back to the original question, how much solar do I need? I'll come back around and show a little bit of how that's handled on a commercial project where the answer is more important. If you're sizing a generator, you do what's called a load analysis. You add up your anticipated loads, and you essentially do a tally and then determine what the right size is. If you're doing this on your own boat, quite frankly, the cost of that exercise would exceed the cost of simply buying a few extra panels and controllers. And then too, on a private boat, I think what happens is the amount of energy use expands to suit what's available. We tend to buy gadgets to soak up any extra power we've got, and so you can't have too much solar input. Consider also that this is August, and at 9 o'clock in the morning I'm at near full charge, but by October, November, December, where the days are considerably shorter and the sun is lower on the horizon, that's not going to happen. So at that point, 300 watts of power really can't, in most cases, keep up with my daily needs. So I'm limiting this conversation a little bit to what I have here, which are rigid glass panels. The reason for that is that I'm aware that the flexible panels offer a lot more options in terms of mounting and installing on a canvas cover, bimini. However, in order for a solar panel to be flexible, two things are necessary. One is that the covering of the silicon solar cells has to be plastic. It's got to be a clear material that flexes, and that's plastic. Plastics typically have about a 5-year lifespan under high UV exposure. So if you're okay with a 5-year lifespan for your investment in your solar panels, then I think that the flexible and semi-flexible panels can offer you some unique options that I don't take advantage of here. Personally, I think 5 years is kind of a short lifespan for my particular use. And so those panels, yeah, I mentioned two things. One is the plastic flexible surface. The other is that the interconnection between the silicon cells within the panel is metal. It's a wire or a flat strip, and metal connections fatigue when you flex them. So the other thing that leads to the death of those panels is excessive amounts of flexing, such as if you're mounted on a bimini that is shaken by the wind. So balanced against the disadvantage of having these panels stick out the sides, make rafting or docking challenging if I don't fold them, there are some advantages. The first advantage I would note is that these arms are pivots so that they are attached, and you'll see if you look carefully that they're lashed with paracord. That's deliberate. I have actually been hit by another boat that would have broken any kind of rigid mount. Instead, what it did was break the paracord and allow the panel to pivot back out of the way. There was no resulting damage to either the panel or the pivot arm, and all I had to do after that, besides the gouge and scratch in the hull, was replace some paracord. I had no loss to my solar capability from that accident. The next advantage that I would note is the ability to angle or orient the panels relative to the position of the sun. So what I can do is articulate these panels in 2 degrees, horizontal axis and the vertical axis. That means that I can aim the panels to diminish shadowing from either the rigging or the other equipment that's around the panels back here. And I can take advantage of, when I'm on board, being able to position these panels so that I get the maximum output throughout the day. In other words, as the sun gets lower on the horizon, I can angle the panel. A solar panel is most effective when it is normal or perpendicular to the rays of the sun. And so if you want to achieve your maximum output and your panels are fixed mounted, that's only going to occur at the midpoint of the day when the sun is at its highest, generally speaking. So you have a very narrow window of maximum output on a rigid panel setup. With the flexible panels, if I happen to be aboard and I don't mind going out every once in a while and tweaking them, I can maintain maximum output for a major part of the day, and my total yield at the end of the day is significantly higher because of that. So I want to do a little demonstration now to sort of show how the output changes with the angle of the panel. So we're going to start right now. These panels are horizontal. This is the normal position that I leave them in when I'm sailing or when I'm not on the boat. And what we'll do is we'll look at the power output in that condition, and then I'll angle them to eliminate some shadowing and show you how the input increases as I do that. It won't be completely effective today because the tide has us in an awkward position relative to the sun, but it'll be enough to get the idea. So what you're looking at right now, center screen, the lower digital meter is an ammeter that is reporting the current output of my 200 watt solar panels on the pivot arms. Those arms right now, those panels are horizontal. I haven't angled them. Voltage is at just over 13. I've actually cheated here and turned on the freezer and a few other things that wouldn't normally be on, just so that the amperage draw is higher, and we can see the difference as I tilt the panels. So right now horizontal, getting high fours, just about 5 amps from those 200 watt panels. And I can tell you just looking out that not only is their angle not optimum to the sun, but one of them is almost entirely shadowed. So right now you see the flat position output. So to angle the panels, it's pretty simple. I've got this small plastic custom-made cleat, aka piece of cutting board, that controls the forward guy line. There is a downhaul slash back here, the release, and then there's an aft guy line just lashed around the stern rail. Once you do that, the panel is now free to tilt on 2 axes. And as you can see, from horizontal, sun angle is relatively shallow to angled and pointed directly toward the sun. There's a considerable difference. Now I'll do the other side, but truthfully, based on the position of the sun, I don't think that we're going to gain much, because I think I'm going to be shadowed on this side. Still, for purposes of demonstration, it's simple enough to show. Release the downhaul, uncleat the forward guy. In this case, I don't need to change the aft. And actually, I think, whether it will show in the film or not, I don't know, but I can tell looking at this that I just decreased the shadowing on that panel considerably. So now that panel is less shadowed than it was and better angled to perpendicular to the sun. Okay, and now we're at 7.7, which is changing slightly as the boat swings with the wind and current. It was up to about 8. So we went from 5 up to about 8 amps by angling those panels, and that's not a hard fast rule. It depends on how much shadowing you've got. But the reality is I've increased my output 50% by angling those panels. And while that might not seem like much in terms of the actual amperage, you also have to bear in mind as you look at on the right voltage meter that we're climbing toward our upper cutoff point. So some of that might be getting caused by the voltage regulators for the solar panels sort of starting to taper the charge. Reality is you can increase at times nearly double your yield by orienting your solar panels this way. So that I would tout as, other than the gain in real estate from having the panels stick out the sides of the boat, I would say that this ability to articulate is the biggest advantage to these, what I like to refer to as solar wings. So as a final advantage I'd point out to the solar wing installation. In profile, in the horizontal position, the panels just sort of disappear. All you really see from eye level is a silver gray line that's the edge of the panel. This changes a little bit when Charis heels under sail and you can see what's there. But in reality, you don't have this sort of big arch permanently installed on the back of the boat. Granted, I've got plenty of other stuff back there, but you know, the solar panels just don't really add to the apparent clutter from eye level, and I kind of like that. That's not the reason I did it. It was all about gaining real estate on a skinny boat, but it's an advantage. So thanks for coming aboard today, and I hope you enjoyed this discussion. Comment and like. Thanks.